All right, welcome back to Applications of Calculus 2. We are talking about integrals today. So last time we talked a little bit about derivatives. Now we talk about integrals. Okay, and what we learned about derivatives was they are the rate of change. Integrals are going to be the area under the curve. Okay, so the idea of the integral is we are going to we're going to approximate a function here. So we have a generic function. What we're going to do is we're going to take little boxes, okay, and we're going to add up all of the areas for these boxes, okay, and we're going to say that that's going to be my area under the curve. So the definition of this thing, okay, each of these little pieces here, this is going to be a delta x, so it's over change in x, and then this is going to be my y value up here. So this is an f of xi as we go through, and this will be I goes from 1, 2, 3, 4, 5, dot, dot, dot. As we shrink these delta x's down, there's going to be more of them. So if I go ahead and cut all of these in half, right, there'll be twice as many. If I cut them in half, those be, again, twice as many, et cetera, et cetera, et cetera. So we're going to do that, to the point where we're taking that delta x and shrinking it down so small that we're going to end up with a sum, all right, that's the capital letter S for sigma, or capital letter Greek S, and we're going to say I goes from 1 to infinity of my delta, my f of xi, right? So each y value times the width of the delta xi. Okay, so I need this limit as delta xi, the delta x goes to 0, okay, for all of my xi's. And when I take that limit, what we're going to end up with is a sigma, which we don't use a sigma anymore. We use an elongated s for sum of f of x dx, and that is the idea of my integral. Okay, we're not going to be doing a whole lot of the definition, but it's always good to know where things come from. So that's what we have. Okay, as far as what we have for our integrals here, we have our power law. Okay, and this is for when n is not equal to -1. So the integral of x to the n dx is equal to x to the n plus 1 over n plus 1, okay, plus c. Okay, and just like derivatives, if I have several x to the n's to deal with, I can go ahead and distribute this integral through each of the polynomial that I'm dealing with. Okay. Now, what happens when n is equal to -1? So when n equals -1, we have x to the -1, or 1 over x dx, and I want to integrate that. Okay. Well, that's a special rule because if I add 1 to it, I'm going to get x to the 0 over 0. That's not going to work out for anybody. So we have a special rule here, and that is the natural log of the absolute value of x. Okay, don't forget the absolute value part of this because natural log has to be function has to work on a positive number. So if we have a 1 over x, and say I wanted to figure out what was going on over here, right? This is 1 over x, and I've got values over here. Well, I can't take natural logs of negative numbers, so we have to go ahead and fix that by making it positive, and the way to do that is absolute value. So don't forget the absolute values, don't forget the plus c. The last rule we have is for the exponential rule. Okay, so if I have to integrate e to the ax dx, we're going to get 1 over a e to the ax. Okay, again, plus c. I'll show you a little trick for this when we get to u substitution, but for now, that's a rule we have to memorize. Okay, so let me do a concrete example of each type here so we can kind of see what's going on. So make sure that I've got this thing and we've got, there's a little bit of an example here. There we go. So we're going to do the integral of, and I've got my 3x squared, let's see, minus 4x plus 7, parentheses, dx. And this is just a polynomial, and that's nice to have. So we're just going to go through and deal with each of these integrals. So this is going to be a 3x to the 2 plus 1, which is going to be 3 divided by 3, minus 4x. X was to the 1, so we're going to do 1 plus 1 is 2, divided by 2. And then we have plus 7, and it's really x to the 0. So if we add 1 to that, we're going to say this is 7x plus a constant of integration. Okay, and that's how you go through and integrate. We're going to clean this up a little bit, and we're going to say this is x cubed minus 4 over 2 is 2, x squared plus 7x plus c, and that's going to be the answer to my first integration problem. Okay, again, this is just reviewing for applications of Calculus 1, but it's probably been, it may have been a year or 3 since you've done this. So the first assignment we have for this class is go back and learn how to do all of this stuff. Okay, so let's see if I try to do an integration of, let's go with e to the 3x dx. Okay, this is going to be 1/3 e to the 3x plus c. Now, a thing you can do is you can take the derivative of the thing you just integrated. They are inverse operations. You should get back the exact same thing you started with. So if I want to take the derivative of 1/3 e to the 3x plus c, let's go ahead and do that. That's going to be 1/3, right? Because the constant flips to the derivative sign. And then we have e to the 3x times its chain rule times 3. And then we move over and take the derivative of this constant. Derivative of a constant is 0. So we actually end up with the 3's canceling. And we end up with e to the 3x. The thing I was trying to integrate was e to the 3x. We ended up with 1/3 e to the 3x. We take this derivative, we get back what we started. Okay, beautiful. So you can always go back and check your answer just to make sure you got that 1/a term in there correctly, just to make sure it actually worked out properly. Okay. Let's go ahead and do one more, and this is just going to be integral of 4 over x dx. The dx and the integral sign kind of work together to make that integral. You could have also written this as 4 to x to the negative 1 dx. And then we can't use our regular power rule because we're going to end up dividing by 0. Can't do that. So we're going to say this is 4 natural log absolute value of x. And again, plus our constant of integration. And that's going to be our answer for this one. Okay, we're going to do a couple more, but here we go. Let's go ahead and try it when we have limits to integration. So let's see if we have, yes. So I'm going to go ahead and say this is the integral from 1 to 3 of 2x minus 5 dx. Okay, so right now we just integrate this as normal. So we're going to say this is going to be 2x squared over 2 minus 5x. And we're going to go from 1 to 3. Now, with a definite interval, that's when you have limits, don't put the plus c. Indefinite interval, there are no limits, you put the plus c. Okay, so now we're going to go ahead and say we need to apply these limits. So go ahead and simplify this. This is going to be x squared minus 5x going from 1 to 3. All right, so we'll go ahead and plug those things in. So putting in the 3, we have 3 squared minus 5 times 3. Okay, and that's my first limit. Minus the second limit, we have 1 squared minus 5 times 1. Okay, so let's go ahead and simplify this. So this is going to be 9 minus 15 minus, and then we have 1 minus 5. So we go ahead and deal with this. 9 minus 15, I think that's going to give us a negative 6. 1 minus 5 is going to be a negative 4. The hardest part of things is always the arithmetic. So we end up with negative 6 minus a negative 4. You end up with negative 2. Okay, so wait a minute. It's an area. How is an area under the curve negative? Like, well, let's show you. Okay, let me go ahead and go back to my original function. It was 2x minus 5. What does this look like as a graph? 2, 3, 4, 5. There's some graphing in this class, not too much, but there's some. So all the stuff that we learned how to graph in college algebra, that still comes back. If I want to get where the 0 is, we have 2x minus 5 equals to 0. 2x then equals 5, and x is equal to 5/2. That's where it crosses the axis. So 5/2 is really 2.5. So it's going to be sitting right there. when x is 3, just because I know we're going to need a 3 here, we have 2 times 3 minus 5. 6 minus 5 is equal to 1. So once we get to 3, we're going to be up here at 1. So what this integral looks like is an area, okay? We went from 0 to 3. So we'll go ahead and make a little mark here. And we'll go ahead and color this in as a little piece here. So we'll say, okay, this is the area that we calculated. Okay. So this was, most of the time, the area under the curve is below the axis. That's why it's negative. Okay. So it's okay for it to be negative. You just have to realize that this is the area that's totally under the curve. And part of that curve is in the fourth quadrant. So it's going to be negative. And that's okay. Right? So it's always a good thing to check. Right, so that is doing a definite integral. Again, the arithmetic is often the hardest part of how this thing works. Let's do another one. Okay. This one's a little bit tricky. This is going to be the integral 2 times the integral from -1 to +1 of the square root of 1 minus x squared dx. Okay. Now, for your class, you have to be a little bit careful with this one, because if you just wanted to integrate this without having to draw a picture, you're going to need trigonometry. You don't know trigonometry. That's okay. So what we're going to say is, well, y equals the square root of 1 minus x squared. Okay. Let's square both sides to get rid of our square roots. We have y squared equals 1 minus x squared. And then we're going to add the x squared to both sides. Let's see what happens after that. So we end up with x squared plus y squared is equal to 1. This is a circle, right? Going back to college algebra, this is a circle. So if we go back and say, okay, let's go ahead and see what happens between -1 and +1. Okay, when x is 0, y is equal to 1. So we end up with this circle here. We're just going from -1 to +1. So we're just going ahead and integrating this area right. I'll get a little erase this guy. There you go. Okay, so we're just going to be integrating between here. So the value that we want is just these pieces right here. Okay, and this is the area that we were dealing with. Remember the area of a circle? The area of a circle is pi r squared. The radius here is 1, so we're just going to have pi times 1 squared. Now, here we don't want the whole circle. We just want the top half of it. So it's 1/2 pi. That's why they put a 2 here. So it's 2 times 1/2 pi. The area under my curve is 1/2 pi. That's what I would take after this. The 2's cancel, and our answer for this is going to give us pi. Okay? So when you see this type of integral, you've got to be a little bit careful with it. You have to realize that, oh, that's right, it's a circle. And we have to go through and deal with it that way. Okay? So be a little bit careful when we have this. Let's do one more, and we're going to go ahead and we're going to integrate from 1 over x, going from -4 to -1 dx. And again, we have 1 over x dx. This is going to be the natural log of x. And we're going to go from -4 to -1. Again, if I wanted to draw a picture of this thing, again, not a whole lot of graphs in this class, but it's always good to get some good practice with it. So that's my graph of 1 over x, going back to college algebra and remembering that. We're going from -1 to -4. Okay, so again, the area that I'm looking for is going to be down here somewhere. So I should be expecting a negative value when I get my answer. Okay, so we went through and integrated 1 over x, we got natural log of x. And again, if you type in natural log of -4, it's not going to work. You're going to need to get absolute values here. So this is going to be natural log of the absolute value of -1 minus the natural log of the absolute value of -4. Let's go ahead and simplify the absolute values and just strip the negative off. So that's natural log of 1 minus natural log of 4. I just stripped the negative signs inside the natural logs there. That's all that happened. Going back to your rules of logarithms, remember the natural log of 1 is 0. If you put that in the calculator, that's just fine. And we actually end up with negative natural log of 4. And we can go ahead and type that out. Let's go ahead and turn this on. So we have negative, I'm just going to say natural log of 4. Now remember that I have a negative sign sitting out there. So this is going to be negative 1.386. We'll say 7. This is equal to negative 1.386. Let's see what we got here. Negative 1.3863. Okay. So that's our answer for what's going on here. Now, if it doesn't say, the good rule of thumb is to go to 4 decimal places. Way back in the day, like in the 70s, 60s, 50s, 40s, 30s, okay, there are these things called CRC books. If you needed a physical constant, I would really love the boiling point of, ethyl alcohol. You would go to your CRC book and you would look up what the boiling point of ethyl alcohol is, and it's going to give it to you in 4 decimal places. Okay, like I need I need, let's say, a heat problem with lead in it. So, okay, how much is the heat capacity of lead? We'll go look that up. So that's what we go through do. They also had a lot of logarithms. They had square roots, cube roots, all sorts of things. But they always went to 4 decimal places. So that's why the rule of 4 decimal places is there. This predates me, so I know I'm blank, but this is order. So this goes back to, what our parents did, what our grandparents did. We're doing the same thing. And we just go to 4 decimal places for all of this. So I'm going to go ahead and stop our video there. So I'm going to say practice, 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 because we're going to do a lot of integrals this semester. And I'll see you in the next video. Okay. So until next time.